All right, so when you log into Azure Databricks, you basically have a very similar look and feel that you would have when you are in a Jupyter notebook. Left-hand side, you have your home page where you're able to see your common tasks, recent documents you've opened, as well as some documentation for importing data, connecting to databases, and so on. What we're going to do is we're just going to go ahead and we have a cluster already created, so I've already fired it up by clicking the start button here. And I'm going to attach this cluster to the notebook that I'm working on. If we did not have a cluster, we would come in here and we would create a new cluster. And this would be basically the basis for the amount of compute that we're going to add to our notebook. But I already have a tutorial here for doing some image detection. I'm going to go ahead and go back here and show you guys the data that I have. As you can see, this notebook is already attached to the cluster. So I'm just going to go ahead and leave it be since it's already attached and it's running. Next thing I'm going to do is I'm going to go ahead and execute some cells by hitting the Shift and Enter button. And here we can see that we're using versions 2.3 of Spark. Next thing I want to do is I want to reference the image folder that I'm holding the Ronaldo and Messi files in my database. And they are right here. So I'm going to go ahead and click on it, and I've assigned a link to the folder. I can then go ahead and look at the folders I have set up for the Messi images, and we can see here the Spark job is running, and here are my Messi images, and you can kind of see them in terms of the name and the size of each image. And I'm going to do the same thing with the Ronaldo images. As you can see, it comes in as a spreadsheet, but one of the nice features that Databricks has is it allows you to do some visualizations without having to code anything. So I'm going to go here and just click on bar chart, and I can create a bar chart from the data without doing any coding at all. Very nice feature that allows you to do some very simple visualizations. I can do this again on this data set here and have, for example, a bar chart or a donut chart, and you can go in here and change it around if you want and make it based on average instead of the sum. The nice feature within Databricks is you can create a dashboard off of this data without having to do any type of coding. So I can come in here and click on add to a new dashboard, and it adds it in there. And I can give this dashboard a name and call it Cool Dashboards. And I can go back to my notebook and come down here and say, let's add this awesome donut chart to Cool Dashboards. And if we go back to Cool Dashboards, we now have two charts together. And we can go ahead and hit Present Dashboard and get our dashboards nice and up and running. Just a cool feature that you can do to sort of get an idea how to create dashboards from scratch and visualize the data for upper management without having to take it out and build a more of a structured dashboard like a Power BI. Anyways, I digress. We'll continue here with the data that we have. We're going to do some simple SQL and image reading. We're going to bring in some libraries to do some of that reading, because what we want to do is we want to be able to create a model that can detect Ronaldo and Messi images and see how well they can create them. So what I'm going to do is I'm going to bring in these libraries, and as you can see, we're using Tensorflow in the back end. And it says here, Tensorflow is an open source software library for data flow programming across a range of tasks. It is a symbolic math library, so it gives you all this new cool stuff right on Wikipedia. You can get that information without having to even leave. So some nice features that you can get out of Databricks. So what I'm going to do is I'm going to label these images. I'm going to say all the Messi images, I'm going to label them with a 1, and all the Ronaldo images, I'm going to label them with a 0. And that's kind of what I'm doing here is I'm creating a column called Messi, called label, and Messi DF is going to be the Messi data frame, and Ronaldo DF is going to be the Ronaldo data frame. So now if I'm going to go in here and just going to create a display Messi DF, and we can see while it is running, this is going to be a big data frame because it's extracting image structure. What is it? It's extracting the origin, the height, the width, the number of channels, all that stuff it's getting out of the image itself. But it's also getting the see all this information it's pulling out of it, and all the way in the very end, if I can just hover towards it, let me see if I can, will even let me, it's so, yeah, it's not even gonna let me do that, but you can look here and we can just say, get me, show me the, we'll do a bar chart here, and we will put the plot options, and I'm just gonna say, give me the label. So labels are gonna all be 1. And why did we do that? Yeah, all the labels are gonna be 1. That's kind of how you know that all 30 images of Ronaldo, all 30 images of Messi are going to be 1. All right, now let's go ahead and do some minor transformations here, just to kind of see how you can do transformations using both Python and other coding skills within SQL. So if I want to know, like, if I want to group by the image height of each image, I can use Python scripting here, basically to say, give me the image height, group it by it, and then give me a count by descending or by descending row count or count of appearance here. So this is basically what we call Python scripting. As you can see, 183 pixels comes up 9 times, and 180 comes up 1 times. So if you add all these up, it should be 30. So this has got 9, 16, 20, 22, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 30. So these are the 30 images, how they're ranked up. But you could say, hey, I don't really want to do Python. I'm not a really good Python guy. Well, we can take the data frame that we just created. We could push it out to a temp table or a temp view. And we can run the SQL instead and get the same exact output that we had here. We can get it right here. Notice that I have to specify this as SQL before I run it by saying %SQL, because if I don't do that, it's going to think it's Python, because this is a Python notebook by default. So if I run any other code, I have to explicitly state it. So if I took the % away, this SQL header grays out. If I go ahead and run it, %SQL, like this, and execute it, now it's going to execute for me. It's going to execute it for me in SQL script. So we're going to go ahead and let that do that, and we'll see what we will get. And lo and behold, we get the same, the height 183 here, up 9 times, which is the same that we got up here, 183 9 times. So pretty cool. Basically, you can run your transformations in many different languages. Now we're going to do our split our data into 50-50. Now, since we're doing transfer learning for this, we don't need to use as much data for training. And so I'm going to take 50% of my images for training and 50% of them for testing. And that's what I'm doing here with the random split. I'm going to go ahead and do that. I create 4 data frames, and I'm going to combine the training data frames into one, and I'm going to combine the testing data frames into one. So now I have 2 data frames. Really, that's about the extent of the transformations we're going to need to do. The last part that we're going to work on is we're going to create a model, and we're going to take a pre-trained model that had a big neural network, and we're going to take the last strip of that, the last layer of that neural network, and we're going to freeze that one, and we're going to use, instead of using the images that we're already pre-trained on, we're going to use our 30 images of Ronaldo and Messi to be able to test on our other 30 images and see how accurate it is. So here is where the part where we're going to bring in some models for classification and to create our pipeline. And all the code that we're going to do for the training is here in 3 lines. This is where we're setting up our pipeline, and then we're just going to train our model. I'm going to go ahead and do that right now. And it looks like our job ran, and it took about 30 seconds to run. Now we're going to evaluate our model accuracy against our testing data. We're going to see how well we're going to get. So drum roll please. And since I'm the only one here talking to myself, I will just do my own drum roll. Alright, and we're going to go ahead and see how well we did. And it's running it right now. And it's coming back. Let's see how well we did. I'm going to predict an accuracy of at least 90%. How about that for predictions? That's pretty high. That's a pretty high standard there. And it looks like our accuracy is 93.75%, which is pretty good. That means we probably missed about 1 or 2 images incorrect. Let's see how we did. I'm going to do a cross tab here to get a type 1 and type 2 prediction and see how well it is. We'll run this and we'll see what we get. And it looks like we got 16 messy images correct and none of them incorrect. And we got 14. Well, we got 14 Ronaldo images correct and none of them incorrect. We had 16 that were correct for Messi, but 2 of them were misclassified as Ronaldo. So those are the 2 that got us wrong, that got us down to 93.8%. Still a very good score. So why don't we look and see which one of those images were the ones that came incorrectly. So I'm going to do a little bit of test to see how close we were in accuracy. Well, it looks like it came back here. It looks like these 2 images are the ones that came back incorrectly. Number 26 for Messi and number 19. Number 26 was way off. It only gave a 7.4% accuracy that was Messi. And this one here said it was only a 34% chance that it was Messi. So those were the ones that were off. Everything else is accurate. So let's look and see if we can see those images and get an idea of why they could have been off. Alright, we're almost done getting the file name of the ones that were incorrect here. So here they are. So now I'm going to display the first one that was incorrect. And here it is. And the second one that was incorrect is right here. So these were the 2 that were incorrect. This one here, I have a feeling this one was wrong because there were 3 people in the image. And even though it's a clear shot of Messi, you don't really tell if these may have caused some type of a contamination in the image. This one here, this one, it could have been something he was doing with his hand gestures that may have detected that this could be a Ronaldo picture. You never know. You'd have to go back and look and see some of the features that were being identified. But overall, I think for building a transfer learning model, only 30 images for training and 30 images for testing, I think we came up with a pretty good model here to do some Ronaldo Messi detection.